Welcome to Psych 319, Chapter 9, Part 2. So continuing on other ways of explaining category formation, um, in addition to the schemata view, there is the knowledge base view. So that, according to the knowledge base view, categories are logically related. So they share some kind of functional relationship. So think about these words: look, time, wrist, clock, and wears. What's the object that I'm talking about? We probably guessed right away it's a watch. But it's amazing, out of all the objects in the world, millions and millions and millions, that it only takes 5 words for you to narrow down to one very specific object. Why? Because there's only very few objects that could fit that description, and watch shares a very functional relationship to these other words. These concepts are so closely related, it's very difficult to describe what a watch is without mentioning these other concepts. In fact, there's a whole board game based around this idea called Taboo. In the game Taboo, you're given a number of words, like up here at the top, you're given the word purple, and your job is to describe that word without using it or any of the words that are closely associated with it. And if you've ever played this game, it's actually very, very, very hard, because it's hard to describe the color purple without using, whoops, I've already done it, using the word color, for example. They're very functionally related. So, how do we take all this stuff, and how do we summarize category formation given what we've talked about up to now? How do we acquire new concepts? The best way I like to describe it is think about how children acquire knowledge. Oftentimes they start off with an exemplar. Their parent tells them this is a cat, the first time they meet a cat. And now they have a specific example and a pairing association with that. They say, it's got fur and scratchy and it likes milk from a saucer, it's a cat. And then eventually they develop a prototype. They go through meeting several cats, and then they sort of learn what makes a cat and what doesn't. Eventually they'll run into a dog, and they'll have to learn what makes a dog different from a cat. And they develop schemas about theories and patterns of behavior about not only what do cats look like, but the sort of behaviors they have, what makes them what they are, and how they're functionally defined. So different scenarios, different situations also seem to require different strategies. We tend to develop schemas for what cats do, but we don't need a script to identify what a cat is. So it tends to be feature-based stuff tends to be more useful when you're identifying an object. But when you're developing a script or a scenario, a script or schema, it's more likely that you're going to develop that based on knowledge-based views or schemata-based views. So I want you to try and find the prototype for this set. The prototype, if you didn't already guess it, is a red octagon. And what I did here was I took that red octagon, the prototype, and I just changed it along one feature dimension. Either elongated it or made it fat, or took away one side or made it small, made it big, changed the color. But all of these members have one logical link between the prototype. And you can see that some are very different from others. So we can quickly get to very different looking things by just a couple links of logic away from a prototype. So sometimes you learn this stuff by example, like in an exemplar, but sometimes you learn what a prototype is implicitly. Like you may have looked at this set and not known what the prototype was, but then when I showed it to you, it might have made sense. So it's sort of like your brain is averaging as you go through life, and if you were forced to say, well, what is my ideal phone, you could pin it down and describe it, but up until that point you might not have thought about it. So the brain has to do two things. It has to assess the similarities between members and the differences. There's many ways to do this. You can either do it all at once for all the features and all members of a set, or you can look at each member across time one by one. So according to that strategy, the second strategy, you would use one member as a temporary prototype and update your notion of what the prototype is as you inspect new members of the set. And of course, different strategies are more effective for different conditions. Um, some knowledge can be acquired explicitly, um, meaning that you can find out right away or by somebody telling you, and some is acquired implicitly. You might gain that knowledge automatically without ever really trying to gain that knowledge. So if I ask you what the prototype for this is, you might say, oh, it's pretty simple. It's a blue circle. And you might have been able to do this using the simultaneous scanning method, where you look at all members of the set all at once, because it's easy to do. But I might show you this set and ask you, well, what's the prototype of this? The prototype for most people probably is picture 7, 8, maybe 9, but most like somewhere between 7 and 8, where the picture of the face is half woman and half leopard. And maybe you had to go through each one serially, one by one, to determine what the prototype was before you settled in on an average one. So the simultaneous scanning method might not have worked on this one. You had to scrutinize things a little more closely and use that serial scanning. Here's another way of acquiring a prototype. I want to show you these 4 objects. They're called greebles. Pay close attention. So look at those 4 objects. Now, what are these 4 objects? Well, they're greebles, I just told you. They're members of the same set. Do they differ from the others? I don't remember. Are they the same picture? Yeah, they're the exact same picture. They could have been slightly different. But what I did is I taught you by exemplar. I just quickly told you, I said, this is what these are, and you quickly store that. It's a great way to start off a category. And then in the future, I might show you different types of greebles. For example, some of these greebles are males and some are females, or some might be happy and some might be sad, and I can tell you which ones are which and introduce new members to the category of the set, and your notion of what a greeble is will change over time. So language is a big helper. I can just tell you what categories are. That's an interesting aspect of being human. So how does this line up with members of what we've learned about long-term memory? Well, they're very closely related. If a prototype is extremely easy to learn, or we have a salient exemplar, we can create a concept around that really quickly. According to the connectionist neural network model of memory, we can represent all the features of that concept in a network. As new samples are encountered, then we compare that to the prototype, and connections between the nodes of that network are strengthened or weakened depending on whether that new example is similar or different from the prototype. So for example, if I show you birds and you're going through life and you think that all birds fly, and the next bird I show you is a flying bird, then you think, okay, great, all birds fly, and that network and the links between those, the nodes in that network, are strengthened. But if I show you then a penguin, then you have to radically change your notion of what a bird is. You realize that all birds don't fly. And then you have to sort of rethink what features define a bird. And this is what it's like to grow up as a child. I mean, you're learning, and you start with an exemplar, and you move to a prototype through time, and then you have to constantly update that prototype with new members. Anyway, hope that makes sense, and I will see you in Chapter 10.